Namaste. My name is Prakash Chitre. I'm an independent researcher and the author of the book of Intellectual Heritage. Drawing from one of the chapters of the book, I prepared a set of 8 videos, namely archaeological evidence of ancient Indian knowledge. I would like to mention it here that the archaeological evidence of such knowledge is one of the 12 distinct groups of evidence I was able to identify and classify uh, and which have discussed extensively in my book, in various chapters of the book. In case you are keen to know or interested in knowing what the four groups are, briefly, uh, please refer to my interview taken by the Center for Indic Studies of the Indus University of Ahmedabad, and I have provided a link to it in the descriptions. First, an acknowledgement. Their knowledge of civil engineering, as seen in town planning, etc., we have seen in the earlier parts. Now, here we're talking about port and dockyard construction. Lothal in Gujarat, 5,700 to 4,600 years before present. Uh, an ancient port and a dockyard were found in Lothal, Gujarat. Several other very important findings were made in this site, some of which have been discussed elsewhere in this presentation. A beautiful National Maritime Heritage Complex is coming up at Lothal, close to the ancient town. One can visit the wonderful archaeological site as also a museum showcasing various objects found there and see even a replica of one of the ships the seafarers of ancient Lothal sailed in to traverse the oceans for trade. They were traders. Um, if any of you happen to go to Ahmedabad and you have some time, you can go to Lothal. It's about just about 80 kilometers from Ahmedabad. Civil engineering, construction techniques for wells. Unique and effective techniques were used to design and construct strong wells. One of these was to build perfectly circular wells, not rectangular or squares. It was perhaps an invention because no circular wells have been found anywhere in the world, anywhere else in the world of that antiquity. Even the Romans, who lived some several thousand years after the Hindus, Saraswati Sindhu Civilization, they lived about 2,000 years back, as all of you know. They were excellent civil engineers. Look at the aqueducts they made to bring water into the city of Rome, and their sewage system. They were all wonderful. But even they did not think of making circular wells. They made them rectangular or squares, and in a high waterbed region, the water would seep up and dislodge the bricks, which would fall in, and they had to redo or reconstruct the wells from time to time. That didn't happen in Lothal. I'm sorry, in the Sindhu Saraswati region. The bricks of the walls of the circular wells in Mohenjo-daro, for example, were trapezoid in shape and not rectangular. In high groundwater level regions, it prevented the bricks from falling into the well. Now, a trapezoid, as all of you know, is a quadrilateral where only one set of sides are parallel to each other, one side being slightly smaller than the other side. Now, they made their bricks in this shape, and one side was only slightly smaller than the other side. The smaller side faced the interior of the well, and the larger side faced the exterior. Now, because of the shape, even if the water seeped up, uh, the shape prevented the brick from slipping in, as the larger side faced the outer area. In some cases, they dug a larger pit around the well, then constructed four supporting walls, all attached to the wells at 90 degrees to each other, and then filled up the empty space around the well. It added substantially to the strength of the structure. Now, these walls were at 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock. And the structure, these walls, supporting walls, reinforced the well considerably. Of course, after this, they filled in the empty space, and the well was ready, a strong well. Uh, the point that the Harappan or Sindhu Saraswati wells were strong is seen also in Mohenjo-daro. They found as many as 700 wells, and Mohenjo-daro is in a high groundwater level region. Yet the as many wells as that survived. Some wells were also built by placing identical terracotta rings one on top of the other. Prefab, yes, they were prefabricated, and of course they must have made molds, perfectly circular molds, to make these terracotta rings, and they were used to making molds, as can be seen uh, by the identical from the identical bricks they made, which we will discuss in the next slide. Lakhs of bricks. Metrology, mathematics, a good sense of proportions, and town planning. The dimensions of their bricks, length, breadth, height, in almost all towns in such a vast region were uniformly in the ratio of 4 is to 2 is to 1, a few in the ratio of 3 is to 2 is to 1, and fewer still in 2 is to 2 is to 1. Most of them were in the ratio 4 is to 2 is to 1. Now, this ratio, 4 is to 2 is to 1, is even now considered as the optimal ratio for effective bonding. And they did that 6,000 years back. The structures such as the boundary walls didn't stop with the bricks. The structures such as the boundary walls, marketplace, stadiums, water reservoirs, lower town, upper town, citadel, etc., were all with integral ratios of their length and breadth. They were not in fractions. Maybe they were, say, 4 is to 11 or 7 is to 31 or whatever, depending on what the structure was. Dholavira went one step further. It is regarded as the most proportionate city. Here, the dimensions of the structures were not only in integers, but were in fact in squares and cubes. For example, 4 is to 9, 8 is to 27, etc. This shows their knowledge of mathematics. They knew their maths. One of the stadiums in Dholavira is huge. It could have seated as many as 10,000 spectators at a time. So they were civilized enough to have uh, a sport. Now, I'm not talking about the Colosseum in Rome. That is different. Uh, but a normal sport, which could be attended by a large number of uh, spectators, as many as 10,000 of them. In Kalibangan, the streets were at right angles to each other and were precisely north-south and east-west grid, thus dividing the city into blocks. In Mohenjo-daro as well, the streets were at right angles to each other and thus divided the city into blocks. So they knew their town planning in so many aspects. For example, the drains had a slight gradient so that the effluent water would flow out and not stagnate. I think we have discussed that in the earlier months. Precision of microscale geometry and measurements. The terracotta scale found at Kalibangan and the ivory one found at Lothal, these were precisely uniform divisions on the entire length of the scales. All the smallest divisions were exactly 1.75 mm in the case of Kalibangan and 1.7 mm in the case of Lothal, and these were uniform in the entire length of the scales. Compass-like device for drawing circles was found at Mohenjo-daro. Thick shell-like objects were found at Lothal, with slits which are likely to have been used to measure angles on plane surfaces. Segments of perfect circles, i.e. arcs, were found on pottery and tiles as space fillers in complicated main designs. Perfect arcs. These findings show a sound understanding of microscale geometry and measurements. Now, their knowledge of microscale geometry or mathematics in entirety did not end with the civilization. It continued thereafter. One example is that of Bodhayan Shota Sutra, written by Bodhayan, who lived 2,800 years ago. He worked out, he codified rather, the formula a square plus b square is equal to c square, codified probably an earlier Indian knowledge. So a square plus b square is equal to c square in a right angle triangle. He also worked out the first seven triples. A triple in this context refers to the three sides of a right angle triangle where all three sides are in integers. The first such a triple is 3, 4, 5. 3 square is 9, 4 square is 16, 9 plus 16 is 25, which is 5 square, which is the hypotenuse. Sadly, his work, the Bodleian theorem and the Bodleian triples, came to be known as Pythagoras theorem and Pythagorean triples, although Pythagoras lived some 300 years after Bodleian. Now, Bodleian did a lot of other work as well. For example, he worked out the value of square root 2 correct up to 5 decimal places. Now, as you know, 2 is a non-square number. So it's a square root doesn't have a finite value. As you go on computing, it leads to an infinite series of numbers. Now, he worked out the 5 correct places, decimal places of square root 2. Now, square root 2 is also related to the formula a square plus b square is equal to c square. Uh, 1, the vertical is 1, the base is 1, and the hypotenuse is square root 2. So 1 square plus 1 square is equal to the square of square root 2. 1 plus 1 is equal to 2. Similarly, he also did a lot of other work in geometry. He didn't stop at just this. He was a geometrician. Now, this brings me to the end of my part 4 of the set of 8. Thank you very much, viewers, for taking interest in watching this video and for your time and patience in doing so. I sincerely hope that you liked it. Please do write your comments, queries, etc., so that I can respond at the as early as possible. In continuation, I shall upload part 5 in a day or two. Do look out for it. In part 5, I shall continue talking about the Saraswati Sindhu Civilization and the evidence found there. In part 6, 7, and 8, I shall discuss the archaeological evidence found in other parts of India, such as Madhya Pradesh, Maharashtra, Karnatak, Andhra Pradesh, Telangana, Tamil Nadu, Kerala, etc. So until then, namaste, goodbye, and thank you once again. And I look forward to meeting you again in the remaining parts. Thank you.